find the sum of this expression. This is funny because now that I read it, it doesn't make any sense. This is a sum, so you want to find the value of this sum. I'm not sure if this is how the question is written, but if it is, then it is not. It is not so clever. So we should try to find the value of this sum. Because if I had said find the sum of this sum, that would be very, that would be something. So for this, we need to make a very simple observation that this is the binomial expansion. So this is a binomial coefficient. And when I say the binomial coefficient, the first thing that should come to your mind is the binomial theorem, which states the following. It says that if you want to expand x plus y to the n, you can expand it as follows. So let's say you want to expand x plus y to the power of 3. You can expand it as x to the third plus 3x squared y plus 3yx squared plus y cubed. And the way you get those coefficients is like this. And what I'm doing here is I'm adding the upper two values. Always adding the upper two values to make a triangle. And I start here from, this is k is equal to 0, k is equal to 0, k is equal to 1, 0, 1, 2, 0, 1, 2, 3. And for the rows, for each row, what we have basically is we have, this is the row for n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. So we discussed this in the tutorial, but if you were not there, or if you do not remember, this is how you write down the Pascal triangle. Of course, it goes on and on, but what I want to say here is, if let's say you want to get 2 choose 3, then you look for 2, index 2 and number 3. So actually it's the opposite, 3 choose 2. Then it is 3 choose 2 is 3. And if you substitute, this is 3 choose 1, this is 3 choose 2. And there's a 3 choose 3 which is equal to 1. And there's a 3 choose 1 is equal to 1 also. You can of course check this. This is not really relevant for the question. It's just a good refresher. If you already know what this is. If you do not, then I'm glad you already got the chance to see it. So this is just an example on the side. And what we can do now is we can try to see what happened. And here's what I mean by this. Now, we start with this and we go to whatever we have here. And it begs the question, how do you go from here to there? And I claim that it is not too difficult to see it. You can try to pause the video and think about it. Maybe a hint would be that you would choose a certain value for x and a certain value for y. That would actually work. And these values are, we choose x to be equal to y equal to 1. Then in that case, this expression is going to be equal to, on the right, it's going to be equal to 1 to the k and 1 to the n minus k. And remember that 1 to the power of anything really is just 1. So we get this expression. We get this expression times 1 times 1. But we can just remove the 1's. And on the right, I want you to notice that since we've chosen x and y to be 1, we can write this as 1 plus 1 to the power of n. And let me see now. I think 1 plus 1, 2. So this is going to be equal to 2 to the n. That's going to be our answer for this exercise.